OK，可以开始了。
Hello, Professor. Here is Group 10. Our topic is coupon reduction prediction for online to offline comments. Next, please. Today's presentation contains of four parts, which are introduction, data, features, and experiments. First of all, I will introduce the background of our project briefly. Next, please. Online to offline currency is a business model that merchants use viral online advertisements to attract potential customers from various online platforms. Customers can get coupons online and use coupons to buy things in online stores and offline physical stores. The object of our study uh, is the acceptance and use of coupons. This is because that we found a large number of customer coupons were wasted after they were given, and sending wasted coupons may have unnecessary cost or marketing expense and erodes merchants' brand reputation. If we can do the coupon reduction prediction, coupon will be placed more precisely so that it can get more target user and the marketing cost would be eliminated. Merchants can get high overall return and customer loyalty would be increased. Our goal is to accurately predict whether user will use the received coupon within a specific specific period by using machine learning. The prediction model will be able to personalize the coupon placements to customers. Next, please. In order to reach our goal, our task is divided into three main steps. First, we will analyze the data to find trends. In this part, we mainly use the pandas, NumPy, and so on. Secondly, we get corn factors through the feature engineering. We mainly use tools of pandas and sklearn. Finally, we train the model and do the experiments to predict the probability. We use three classifiers. They are random forest, LightGBM, and XGBoost. Next.
Our dataset provides the real data of online and offline retail consumption behavior. To protect the privacy of users and merchants, all data is treated anonymously with partial sampling and necessary filtering. There are two tables in total. Table 1 is about offline consumption and coupon receiving behavior of users. This table provides the detail of offline retail consumption behavior from January 1st, 2016 to June 13, 2016. The table has attributes like user ID, machine ID, etc. We can see its attribute from the graph. For example, the attribute of the first table. This row means the user ID is 2029232 and the user has a coupon which is supplied by the merchant whose ID is 3AA1. The coupon ID is 11951, and the discount rate means there is 20 yuan off if the consumption of coupon holder in physical store is over 200 yuan. Distance colon 0 means distance between the closest offline store to the coupon user is less than 500 meters. The user received this coupon on January 29, 2016, but didn't redeem it because the date column is equal to none. Table 2 is about the online consumption and coupon receiving behavior. The table presents the detail of online retail consumption behavior from January 1st, 2016 to June 13, 2016 as well. In compare with Table 1's attributes, Table 2 have one more column called action. Action have three values including 0, 1, and 2. 0 means the user clicked the website of the one merchant. 1 means the user have purchased something from the one merchant. 2 means the user have received a coupon from the one merchant. Based on the consumer behavior, we divide user into three categories. Users who have consume behavior but don't use coupon is labeled as -1. Those user coupon to consume is labeled as 1. Other users are labeled as 0. And we can see the number of coupons received related to the number of coupons used through the graph. We found just a few people use coupon to buy something. The majority of people get coupon online but do not use the coupon offline. We would like to find out the reason and figure out what feature impact the consumer behavior. Then we need to explore more features, and reading will introduce this part.
Okay, as we all know, in the problems of classification and prediction, feature engineering is very important. This question provides a record table of users' offline consumption and coupon collection verification behaviors, and a record table of users' online clicks, consumptions, coupon collection verification behaviors. What needs to be predicted is whether the user will write off the coupon after receiving the coupon in July 2016. In our project for doing future engineering, we need to do some data pre-processing work. We mainly use data frame to extract a feature from the data. First, we do the non-value processing, change the non-value from type string to integer type -1. Next page, please. Then for generating labels, we classify the labels to three types. One means users who have coupons and use them. -1 means users who have coupons and don't use. 0 means the other situation. Next page. We consider extracting features from three aspects of the data. The first is coupon related. From discount rate, we can get several kinds of related features. In the raw data, the data format is not standard and contains special characters such as colons. We break it down into four subfeatures like this. P then O is a bill feature, commerce, or discount. Next page. The second is date gap related features. From date, we can get data received, user data received gap. For doing this, we transform date string into timestamp format and compute their gap maximum, minimum, average. Next page, please. The last is distance-related features. Using only distance column, we can get some kinds of related features. Mean distance, max distance, mean distance, median distance. Next page, please. Finally, for extracting feature from dataset, we plan to extract following types of features. Features related to coupons, merchant-related features, user offline-related features, user mention interaction features, and some other features. Next page, please. Here are some samples of our features. It totally has 53 features. More details can be seen on our GitHub website. Okay, next part.
Next, please. Now I'm gonna show you how we make prediction. Our task is to help merchants by sending coupons accurately. Based on different information, for example, the discount rates, the dates that the coupon will be sent, the distance from online shop to the user, and the merchant ID and so on. Then we give a prediction results on whether the user would use it, so the merchants could benefit from our results. We mainly use free classifiers of machine learning. They are attributes like GBM and random forest. Now we will introduce the classifier separately. Next.
One model we use in our project is random forest. So what is random forest? Like its name implies, consists of a large number of individual decision trees that operate as an ensemble. Each individual tree is in the random forest splits out a class prediction, and the class with the most votes becomes our model's prediction. Its flowchart is like this. For each train, the training set the use is sampled from the total training set, which means that some samples in the total training set may appear in the training set of one train multiply times or never appeared in the training set of a train. When training the nodes of each train, the features used are randomly selected from all features according to a certain proportion without replacement. And also it has some advantages like this: fast training speed, not easy to overfit, and easy implementation. Process high-dimensional data without dimensionality reduction or feature selection. And if a large part of the features are missing, the accuracy can still be maintained. Okay, next page.
Now I introduce the SG boost briefly. SG boost means extreme gradient boosting. Um, it is a popular ensemble learning algorithm. It is proposed by Dr. Chen in 2016. SG Boost has good performance, and many research can use it to do the analysis. On the left is the flow chart of SG Boost. We SG Boost. It has many free steps. The first step is to parallelize parallelize uh, parallelize processing. The data is sorted into a block structure. The next step is to find the optimum segmentation points of each feature. The final step is to find the optimum segmentation points. There are many benefits of SG Boost. The first benefit is SG Boost can avoid overfitting. Because SG Boost has simpler regularization, thus leading to a simpler model, it reduces the variables so that it can avoid overfitting. The second advantage is user-defined. You can choose your own objective function as long as the objective function is second-order dividable. The third benefit is parallelism computing. It can help shorten the time of calculating the results with the multi-threading by using the block structures. Next, please.
Although we know the XGBooks algorithm is very powerful, it still has some problems. It needs to traverse the entire training dataset several times at each iteration. In the process of using XGBooks, its training takes a long time to repeatedly read and write the training data. In order to avoid the shortcoming of XGBooks and speed up the training of XGBooks model without compromising accuracy, Microsoft developed LightGBM on 2016. LightGBM, short for the Light Gradient Boosting Machine, is a fast distributed high-performance gradient boosting framework based on the decision tree algorithm. LightGBM uses the histogram algorithm, which only requires low memory and have low data separation complexity. The optimization method of LGB is to retaining large gradient sample while randomly retain some small gradient sample, and at the same time emphasize the information gain brought by small gradient sample. In addition to calculating information gain through the partial sample, LGB also have built-in feature dimension reduction technology. The idea is to merge sparse feature with little conflict. Therefore, LightGBM will perform better than XGBooks in many aspects, like faster training efficiency, low memory usage, high accuracy, support parallel learning, can handle large-scale data, support direct use of category feature. In conclusion, we trained three single model, random forest, XGBooks, and LightGBM. LightGBM perform as good as XGBooks, but it takes less time to get the result. And random forest was the worst in comparison. We believe XGBook can perform better if we have enough time and more information to training. For our future work, we will try a two-layer blending. First, the training set is divided into two parts. One part is used for the training of the first layer, and the second part is used for the training of the second layer. Level 1 will train for XGBoost model, for light GBM model, and for random forest model on layer 1. Then we use the prediction result on this model as feature of level 2. And we train the second layer model on D2. We believe the result of blending model will slightly improve compared to the single model. That's it. Thanks for the watching.